Hello dear students, today's topic is about superposition theorem. This is the first topic in our first module. So let's start with superposition theorem. According to superposition theorem, the current through or voltage across an element in a linear bilateral network is equal to the algebraic sum of the currents or voltages produced independently by each source. In other words, the theorem can be stated like this. Superposition theorem states that in a linear network containing more than one independent source and dependent source, the resultant current in any element is the algebraic sum of the currents that would be produced by each independent source acting alone, all other independent sources being represented meanwhile by their respective internal resistances. Independent voltage sources are represented by their internal resistance if it is given or by a short circuit. And independent current sources should be represented by their infinite resistance or should be represented by an open circuit. The points to be noted are the dependent sources are left as they are. The second point is that superposition theorem is valid only for linear circuit. It's not valid for non-linear circuits. And the question is that what is a linear network or what is a linear circuit? Linear circuit is one whose parameters are constant. That is, they do not change with voltage or current. All the parameters will be constant irrespective of the magnitude of voltage or current. Then, while dealing with superposition theorem, some important points to be noted are: first one, independent voltage sources should be represented by their internal resistance or by a short circuit. Independent current sources are represented by an open circuit. Third point is that dependent sources are left as they are. The fourth point is superposition theorem is not valid for non-linear circuits. Now let's move to the problems. Let's consider a simple problem. For the given question, for the given circuit, and the current passing through the 3 ohm resistor using superposition theorem. So the first step is, let's consider the 20 volt source alone. By considering 20 volt source alone, for that current source we are considering only the 20 volt source. Then what about the current source? 5 ampere current source should be represented by an open circuit. So the diagram will be like this. Now the current I dash is marked as the current through the 3 ohm resistance. Now we have to find out I dash. Current passing through 3 ohm resistor is I dash, which will be equal to 20 divided by 5 plus 3. 5 and 3 are connected in series. So the current through the circuit will be 20 divided by 8, that is 2.5 amperes. So we got I dash is equal to 2.5 amperes. Next is step 2. Step 2 is to consider only the 5 ampere source. 5 ampere source alone is considered. For that, the voltage source is represented by a short circuit. Then the circuit will be like this. Current passing through 3 ohm resistor is I double dash. Using current division rule, we can get the value of I double dash. This is current division rule. Current through R1, as per current division rule, current through the resistor R1 is equal to total current into resistance of the other branch divided by total resistance. So we can write I double dash as 5 into resistance of the other branch. We are going to write the equation for current passing through this resistor. That will be equal to total current 5 ampere into resistance of the other branch divided by total resistance. Total resistance is 5 plus 3. So we will get I double dash as 25 divided by 8, that is equal to 3.125 amperes. Then according to superposition theorem, current flowing through the 3 ohm resistor will be equal to sum of current through 3 ohm resistor while considering 20 volt source alone plus current flowing through the 3 ohm resistor while considering 5 ampere source alone. That means I will be equal to I dash plus I double dash. I dash we got it as 2.5 amperes and I double dash is 3.125 amperes. So the net current is equal to 5.625 amperes. Then what are the steps to be followed in superposition theorem? The first step is find the current through the resistance when only one independent source is active, keeping all other independent sources by their respective internal resistances. The second point is find current through the resistance for each of the independent sources. Then third step is find resultant current through the resistance by the superposition theorem, considering magnitude and direction of each current. Not only the magnitude, but direction should also be considered. Now let's move to another problem. Find the voltage across the resistor in the circuit by using superposition theorem. So we have to find out current through this resistor. Here we are having three sources: a 10 volt voltage source, a 2 ampere current source, and a 20 volt voltage source. So first let's consider the 10 volt source here. So we have to redraw the circuit keeping only the 10 volt source and replace the other two sources. 2 ampere current source can be replaced by an open circuit and 20 volt voltage source can be replaced by a short circuit. So the diagram will be like this. Now we have to find out current through this 2 ohm resistor, which will be I dash. So I am marking current through the 2 ohm resistor as I dash. This current is marked as I dash. Now our aim is to find out I dash. So I am redrawing the circuit because this 3 ohms is like this. So no current will flow through the 3 ohm resistor. Here we are having an open circuit. So no current will flow through the 3 ohm resistor. So we can omit this 3 ohm resistance from this circuit. So the circuit will be like this. Now we have to find out the current I dash. In order to find out the current I dash, we have to find this current. Let us name it as IS dash. That will be IS dash. Then only we can find out I dash. In order to find out IS dash, we have to calculate the effective resistance of the circuit. Here, this 2 ohm and 5 ohm are in series. So we can replace these two resistances by a 7 ohm resistor. Now that 7 ohm is in parallel with this 20 ohm resistor. And that parallel combination of 7 and 20 is in series with this 10 ohm resistor. So the net resistance will be equal to 10 plus 7 parallel to 20. Then total current taken from the source, which is IS dash, will be equal to voltage 10 volt divided by effective resistance. Effective resistance is 7 parallel to 20 plus 10. and we will get the effective total current taken from the source as 0.6585 amperes. So now we got this current Is dash as 0.6585 amperes. Now from current division rule, now from current division rule, we can find out the value of I dash. According to current division rule, I dash will be equal to Is dash into resistance of the other branch, that is 20 divided by total resistance 20 plus 7. So I dash is equal to 0.6585 into 20 divided by 20 plus 7. We will get I dash is equal to 0.487 amperes. Then voltage across 2 ohm resistor due to 10 volt source alone will be equal to current due to 10 volt source alone into 2. So that will be equal to 2 into 0.487, 0.974 volt. So voltage across the 2 ohm resistor, while considering 10 volt source alone is 0.974. Now we are moving to the second step while considering 20 volt source alone. So the 20 volt source alone is considered here. This current source is replaced by an open circuit and this voltage source is represented by a short circuit. So the diagram will be like this. Now we have to find out current I double dash through this resistor, 2 ohm resistor. In order to find that, we have to find out the total current Is double dash. Our aim is to find out this current I double dash. In order to find out I double dash, it is necessary to find current taken from the source, which is Is double dash. In order to find out Is double dash, the entire circuit resistance should be calculated. For that, 10 ohm and 20 ohm are in parallel. So we can replace these two resistors by a single resistance of value 6.667 ohm. So the diagram will be reduced like this. These two are combined with a 6.667 ohm resistor. Now current through the 2 ohm can be calculated. That will be equal to 20 divided by effective resistance. Here we are having 3 resistors. These 3 are connected in series. So the current will be 20 divided by 5 plus 2 plus 6.667. That is equal to 1.4634 amperes in this direction from right to left. So the marked current I double dash will be equal to minus 1.4634. This negative sign is to show the direction. The net current is 1.4634. It is flowing from right to left. And we are considering I double dash from left to right. So it should be written with a negative sign. Then voltage across 2 ohm resistor will be equal to 2 into I double dash. That is equal to 0.974 volt. This is I double dash. This is V double dash. Now let's consider the third source alone, that is the 2 ampere current source alone. So only the 2 ampere source is considered here. This voltage source was replaced by a short circuit. Here also we had a voltage source that also represented by a short circuit. So the diagram will be like this. Now we have to find out current through this 2 ohm resistor. Here again this 10 ohm and 20 ohm are in parallel. So we can replace this 10 and 20 with an effective resistance of 6.667 ohms. Now using current division rule, we can find out current through this 2 ohm resistor. Current through 2 ohm resistor, or I triple dash will be equal to total current, that is 2 ampere, into resistance of the other branch, which is 5, divided by total resistance. Total resistance is 5 plus 2. So total current into resistance of the other branch divided by total resistance. Total resistance is 5 plus 2 plus 6.667. We will get it as 0.732 amperes. 0.732 amperes in this direction from right to left. But the standard direction we are assumed from left to right. So I triple dash should be written with a negative sign. Then voltage across 2 ohm resistor due to I triple dash is V triple dash is equal to 2 into minus 0.732. We will get it as minus 1.464 amperes. Now, according to superposition theorem, the net voltage across 2 ohm resistor will be equal to V dash plus V double dash plus V triple dash. V dash was 0.974 and we got V double dash as minus 2.92 and we got V triple dash as 1.464. So according to superposition theorem, net voltage across 2 ohm resistor will be equal to algebraic sum of these three values, which we will get it as minus 3.41 volt. This is the third question. All of you work out this problem, do it as a homework. Okay. Thank you, students.